Okay, here we go. Moving on to Unit 3, the periodic table. This is the first video in the series, video 3.1. Okay, once upon a time, long time ago, there was a dude named Dmitri Mendeleev, and what he did was he took the known elements at the time and he arranged them into a table that other scientists can use. And the way he arranged them was he grouped all of the elements with similar chemical properties together, and he put them in order of increasing atomic mass. What happened was there were these gaps that were left, and he predicted that there were elements that were going to be found in those gaps. And lo and behold, years later, there were elements that were found in those gaps. So Dmitri Mendeleev is credited for coming up with the first periodic table. However, the periodic table evolved from what he said a couple years later and then along came a guy named Henry Moseley, and Henry Moseley was given credit to proving the existence of a proton, and he used this knowledge to expand upon Dmitri Mendeleev's periodic table. He took Dmitri Mendeleev's periodic table, and instead of keeping it arranged according to atomic mass, which is what Dmitri Mendeleev did, he arranged the atoms in order of atomic number, and that's how we have the periodic table arranged today. He took his number of protons and he said, if instead of arranging them according to mass, let's arrange them according to number of protons. We got a much more effective table without any gaps. So Henry Moseley just expanded on Dmitri Mendeleev's initial periodic table. Alright, so now we have to talk about writing some notes down into our notebooks here, and I know you're probably saying, oh, crumb cakes, look at all these notes that I have to write. Take a moment, pause me, write these notes down in your notebook, and then we'll talk in more depth about them. Alright, periodic law. The definition of periodic law says that elements in a periodic table are periodic functions of their atomic number. Remember, Henry Moseley arranged them according to atomic number. Don't get confused. Dmitri Mendeleev started with atomic mass, but today's periodic table arranges the elements according to atomic number. Now, there are 6 bullets here. 1, 2, 3, 4, 5, and 6. We're going to talk about these bullets in the next slides as we go through this. The first thing we have to discuss is the vocabulary of the periodic table. When we see a periodic table, I'm going to be referring to the horizontal rows on the periodic table as periods and the vertical columns as groups. I grabbed myself a periodic table here so that I can talk about it with you looking at it, but you should have one in front of you while you're watching this video. Okay, I'll grab myself a handy dandy pointer. Here we go. The horizontal rows on a periodic table are called periods. It's kind of like weeks in a month, right? If we imagine this would be a month, this would be week number 1, this would be week number 2, week number 3. If you were looking at a calendar, that's how we would read it. And we would start with Sunday and we would end with Saturday, all the way over here. It works exactly the same way. They're periodic. They start with something, they go to the end, and then they start again. So period number 1 has 2 elements in it, hydrogen and helium. Period number 2, which is right here. Ooh, my pointer's not working. Come on, pointer. There we go. Period number 2 starts with lithium, goes all the way to neon. Period number 3 starts with sodium, goes to argon. And again, my pointer's not working, but okay. They're periodic. Now, it's amazing how this periodic table is arranged, and it gives us so much more information than you can ever imagine. But we're going to go through that as we proceed through the notes. So let's go back to those notes. Let me find my squisher. I'm going to call this my squisher. I squish that over to the side. Alright, as you move down, a group or column. Now, a group or a column on the periodic table, here we go, is this. This is a group. This is called group 1. This is called group 2, 3, 4, 5, 6, and so on, all the way over to 18 groups. Okay. Oh, because I don't have my mover and shaker. Okay, so 18 right here, 18 groups. They have some special names. We'll get to them later on in the video. You can see some of the vocabulary is starting to creep up on us. So make sure that you are familiar with the vocabulary. I just gave you what a period is. I just gave you what a group is. You also are going to see words like valence and valence shell. Remember from the last unit, the valence is always the very last shell in the electron configuration, and the valence electrons are the electrons that are located in that shell. So now you look at number 2 here. It says, as you move across a row or a period, and that's this. Let's take period 2 right here. Can't see if my pointer is working. Okay, period 2. Start with lithium. Notice that the number of rings does not change as you go across a period. What is changing is the fact that you're adding a proton every time you go from one element to another. Let's see if this works. Okay, is that a pointer? Yeah. Okay, so lithium has 3 protons, beryllium has 4 protons, boron has 5, carbon 6, and so on, all the way over to neon that has 10. So as you move across a row or period, you add 1 proton to the nucleus. You are also adding 1 electron to the valence shell. The valence shell is not changing. For period number 2, which is the second row here, you have 2 rings. That's not a coincidence, okay? You have 2 rings. I can't point and scroll at the same time, so bear with me here. You have the first ring, or first principal energy level, and you have the second ring. This beryllium has 2 rings. Notice that when you went from lithium to beryllium, you added 1 electron to that ring. Get my scroller dollar here. Scroll across. Boron, you added 1 electron to the outside ring. You got all the way over to neon. And now my valence shell, which can hold a maximum of 8 electrons, is full. That signals that it's time to start a new period. When your valence shell becomes full, you go to the next period. So neon gets a full valence shell, whoop, back to sodium. Now I'm in period 3 with 1 valence electron again. So you wrote that down. The maximum number of valence electrons any element can have is 8. Therefore, any element with 8 valence electrons marks the end of a row or a period. And the next element will be the first of a new row and restart the pattern with 1 valence electron. Kind of like you get through a week. You start with Sunday, you end with Saturday. And then as soon as Sunday starts again, whammo bammo, you're back to the beginning. Okay, so let's smush that thing over to the side. The number of valence electrons dictates the number of bonds an atom or an element can form. When we get to the bonding unit, this will make a little bit more sense. But if you look at all the elements in the first group, which is the vertical column, group number 1. Okay, right here. Group number 1, you'll see that all of them have 1 valence electron. 1 valence electron makes those elements have similar chemical properties. It also makes them so that they all have the ability to make the same number of chemical bonds. Lithium can form 1 bond. Sodium can form 1 bond. Hydrogen can form 1 bond. Before I squish that over there, let's look at nitrogen. Nitrogen has 5 valence electrons. In order to get from 5 to the 8 that it needs, it can form 3 bonds. Phosphorus, 5 valence electrons. It needs 3 more electrons to get to the 8 that it needs, so it can form 3 bonds. There is a little formula for that. We'll get to that in the bonding unit, so don't worry about it. Okay, the next thing is all elements in the same column or group have the same number of valence electrons. Therefore, elements in the same column or group have similar chemical properties. I want you to put a little bit of a star next to that because, ooh, I think I just made a star. Ooh, wait, let's make it blue. No, that is so not a star. Come here, you. Oh, yay, I did it. Okay, so I want you to put a star there in your notes because that's kind of important. They ask that a lot. They say, which of the following elements has chemical properties that are similar to, and they'll give you an element like sodium. When you look at sodium, sodium is in group 1. It's right here. What elements have similar chemical properties? Well, potassium and rubidium and cesium and francium and lithium. All of these elements that are in group 1 have similar chemical properties to sodium. Magnesium and calcium are similar. Strontium and calcium are similar. Anything in group 2 have similar chemical properties to each other. Alright, so let's look at the arrangement of the periodic table in terms of periods. If you do not have this already written in your notes, I'm going to make this yellow. I like this whole star thing. Woohoo! I want you to write it in your notes right there. Periods are horizontal rows and they run from left to right. Now we have a chart here. I want you to take a second, pause the tape, and I want you to write in all of these and check your answers. I'm going to put the answer key, I'm going to give you a way to check your answers in a second. Alright, the vertical columns that run vertically, up and down, okay, are called groups. And again, I want you to take a second and I want you to look at your reference tables, your chemistry reference tables. That's what this thing stands for, CRT, chemistry reference tables, to complete the table below for group 1 elements pictured next to it. If you still need help with drawing the Lewis dot diagrams, okay, this is a kind of a little bit of a review. So again, I'm going to provide the link so that you can check your answers when you're done. Alright, now, the last thing that I want to address in this video are the groups and their names, okay, because we have specific names for specific groups on the periodic table. The groups have names according to what their chemical properties are. The first group, group number 1, is called the alkali metals. Oh, by the way, you should be writing this down in your notebook, okay? Group 1 are the alkali metals. If you want to make a star next to it, go ahead and do that. Okay. Gotta love the stars. Okay. Group 1, alkali metals. They all have one valence electron. You can see that when you look at the periodic table. The valence electrons are 1. They all lose their electron and become positive 1 ions. Very important, they are extremely reactive. And a question that comes up frequently is that they are never found alone in nature. You're not going to be walking down the street and find sodium or lithium or potassium or rubidium laying there on the sidewalk. They tend to react very quickly and they form compounds which are more stable than the element by itself. The most reactive metal, because these are alkali metals, is francium. But francium is radioactive and it's rare, so we can also consider cesium a very reactive metal. Alright, I want to go quickly because I don't want this video to be 20,000 years long. So group 2 are the alkali earth metals. Make sure you write down that information. They have 2 valence electrons. They also tend to lose their electrons and become positive 2 ions. Okay, remember from the last unit, when you lose an electron, you become positive. Positive ions are called cations. So the group 2 elements form positive cations. They're also pretty darn reactive, not found alone in nature, but not nearly as reactive as the group 1. Alright, group 3 through 12, the transition metals. These guys are kind of cool. They're in the middle of the periodic table, and what makes them so awesome is that if you dissolve them in water, you get this awesome color. It could be bright blue, it could be bright purple, it could be green, it could be pink, it could be red. They do ask this quite frequently on a Regents exam. You will see it in your CASEL learning questions. You will see it on your test, on the periodic table tests that will be coming up at the end of this unit. So know, if it contains one of these elements, you're going to see a beautiful color. You don't have to memorize the colors, you just have to know that they're colored. Okay, the number of valence electrons for these vary between 1 and 2, and their reactivity is unpredictable. Some will be more reactive than others. They tend to be a little bit more stable than the group 1s and the group 2s. Like, if you think about it, gold is a transition metal. It's a beautiful color, right? If gold is a transition metal, it is very unreactive. That's why we put gold, when you get something pierced, you use 24 karat gold, because it doesn't react, doesn't bother your ears. Alright, groups 13 through 16 don't have formal names. We call them the boron group, the carbon group, the nitrogen group, and the oxygen group. If you're looking at the top of your reference table, look at the very top element, and you'll see boron, carbon, nitrogen, and oxygen. I'm not going to pull up a reference table because I know you have it in front of you. So there's no real formal names for these. What makes these guys so special is that they contain metals, nonmetals, and metalloids, which the metalloids are located right there along that staircase. You're going to have to know where the metalloids are. Metalloids are not true metals, and they're not nonmetals. They're kind of in between the metals and the nonmetals. Alright, the last two groups are group 17, which are called the halogens, which is derived from the word halide, which means salt former. Okay, so you'll see sodium chloride has that chlorine in it. Let me get a pointer. Right here is chlorine, right? Chlorine belongs to this group 17. Sodium chloride is a salt. So those group 17 halogens tend to be salt formers. The most reactive halogen is fluorine. It's up here. It's exactly opposite of the francium that was in the bottom of group 1. I pulled up a reference table real quick so that you can see what I'm talking about. Alright, fluorine, which is right here. Ooh, that's an ugly yellow color. Let's change that. Okay, fluorine, which is up here, is the most reactive nonmetal. Francium is the most reactive metal. So they're in opposite corners. It's like they're at a boxing match, right? They're in opposite corners, and one is a metal. Francium is the most reactive metal. Fluorine is the most reactive nonmetal. You're probably saying to yourself, what about these guys over here? How come it's not in the upper right-hand corner? Why is it not neon or helium? The reason being is those last group right there are called the noble gases. Let me get the noble gases are unreactive or inert gases. What that means is they already have their 8 valence electrons. They don't want to mess with those. They want to keep those 8 valence electrons, and so therefore they kind of just hold on to them, don't get involved, don't fight anybody, no boxing matches going on there. They keep their 8 electrons, or in helium's case, it's 2 electrons, and they're perfectly happy, so they don't get involved in anything. That's how you have to think about it. The group 17, they have 7 valence electrons, so they're always on the hunt. They're always looking for somebody to give them that last valence electron. I failed to mention when we were talking about the group 17 elements that those group 17 elements also have another really cool feature. And the halogens are elements at STP, standard temperature and pressure. That means normal, everyday standard pressure and standard temperature. That they have all the phases of matter. Fluorine and chlorine are gases at STP. Bromine is a liquid at STP, and iodine is a solid at STP. So we've got all the phases of matter in that particular column. So, very last thing that I want to say is make sure that you're familiar with what a period is, what a group is. At the end of this, you should be able to tell me the names of all of the groups, group 1, 2, 3 through 12, 13, 14, 15, and 16, which are the boron, carbon, nitrogen, oxygen group. They kind of don't have their own formal names. 17, which is the halogens, and 18 are the noble gases. You should also be able to tell me some general properties about each one of those groups. So the metals, which are located on the left, the alkali metals, the alkali earth metals, and the transition metals. Then we moved our way over to groups 3 through 12, which are the transition metals, and then we had 13, 14, 15, and 16, which are kind of moving towards the nonmetals. They have both metals and nonmetals in them. And then we have halogens, which are entirely nonmetals, and noble gases, which are entirely nonmetals. Okay? Until next time, if you did not catch it, if you did not write all this stuff down, make sure that you scroll back during the video and make sure you write down all of the groups, all of the definitions for period, understand the vocabulary of valence and valence electrons. If you still need help, come and see me. Until next time.